Lesson 11.8, Solving Rational Equations. I'll teach you two methods for solving rational equations. The first is the cross products method. The cross products method is the method used when solving proportions. It can be used when the equation is in the form a over b equals c over d. Let's look at number 1. 3 over x plus 5 equals 2 over x. You will set up an equation by cross multiplying. So 3 times x is 3x. X plus 5 times 2 is 2x plus 10. And then we solve for x. So let's subtract 2 from both sides. And we have x equals 10. It's always important to go back when you solve an equation to see if it's an extraneous solution. Remember that when we have variables in the denominator, you may have a solution that is extraneous. In other words, a solution that would make your denominator equal to 0. So always go back, plug 10 into each denominator to make sure that 10 is not extraneous. And it isn't. It is a valid solution. Okay. Number 2. 7 over y minus 3 is equal to 3 over y plus 1. Let's cross multiply. We have 7y plus 7 is equal to 3y minus 9. Again, we will solve for y. So let's subtract 3y from both sides. And let's subtract 7 from both sides. And let's divide by 4. And don't forget, please, to check to see if negative 4 may be an extraneous solution. Just go ahead in your mind and plug in negative 4 for y in each of the denominators to make sure that it doesn't make my denominator equal to 0. Try number 3 on your own. Pause the video now, come back and check your answer. Okay, the answer is x equals 4.5. Okay, the second method that you will use to solve a rational equation is using the least common denominator to eliminate all of the denominators and write an equation that we can solve. Okay, so number 4, write this down. 4 over y plus 5y over y plus 1 is equal to 5. So the first thing that you have to do is determine what the least common multiple of the denominators is. The least common denominator, in other words. So my denominators are y plus 1, and 5 over 1. What I will do to keep this kind of neat is I will rewrite this expression and show you how I'll multiply each of my terms in an effort to eliminate the denominator. Watch. 4 over y plus 5y over y plus 1 is equal to 5 over 1. Okay, so I'll do this in a different color just so that you can see it. What I want to do is multiply every term by y plus 1. So y times y plus 1. So this is going to be multiplied times y times y plus 1, y times y plus 1, and then y times y plus 1. Okay, now this is what's going to happen. When I multiply, I'm going to eliminate the denominators. So here I have 4y plus 4. The y plus 1's eliminate here, and here I have 5y squared. And here I have to multiply 5y times y plus 1. So I have 5y squared plus 5y. Okay, let's simplify and solve. I have 5y squared terms on both sides, so I know that those will cancel each other. I'm going to subtract 4y from both sides. So I have 4 equals y, and that's my solution. Okay, please don't forget to go back and plug 4 in to the denominators to make sure that it isn't an extraneous solution. And it isn't. It is valid. Okay. Number 5, 3x over x minus 1 plus 6x minus 9 over x minus 1 is equal to 6. Again, I'm going to rewrite this just to keep it neat. Just spread apart, giving myself enough room between terms to multiply times the LCD. So I'll rewrite this way. 3x over x minus 1 plus 6x minus 9 over x minus 1 is equal to 6. So the least common denominator here is x minus 1. And what we'll do is we will multiply every term times x minus 1. All right, so that will cancel. 3x, that will cancel. 6x minus 9, and I will distribute here 6x minus 6. Right? Let's go ahead and simplify. 3x plus 6x is 9x minus 9 is equal to 6x minus 6. Let's go ahead and subtract 6x from both sides. 3x minus 9 is equal to negative 6. We'll add 9 to both sides. 3x equals 3, which means that x is equal to 1. So I have one solution, x equals 1. Got to go back and make sure that it's not an extraneous solution. An extraneous solution, once again, is a solution that makes my denominator in any expression equal to 0. So I look at my original problem, and if I were to plug in 1 for x in my denominator, I find that my denominator will equal 0. So this is an extraneous solution. Since it's my only solution, this equation has no solution. Number 6. Y plus 2 over y minus 2 minus 2 over y plus 2 is equal to negative 7 over 3. Right? My least common denominator is 3 times y minus 2 times y plus 2. Okay? So I'll rewrite this to make it nice and neat, to have enough room in between terms so that I can multiply. So y plus 2 over y minus 2 minus 2 times y plus 2 is equal to negative 7 over 3. All right, let's multiply every term by my least common denominator. So I'm going to multiply this by 3 times y minus 2 y plus 2, 3 times y minus 2 times y plus 2, and 3 times y minus 2 times y plus 2. Okay. What this does, again, is we want to cancel out and we want to eliminate all of the denominators and have an equation that we can solve without dealing with denominators. So y minus 2 eliminates y minus 2, and I'm left with 3 times y plus 2 times y plus 2. I'll do this in steps so that we can follow along. Minus y plus 2 and y plus 2 cancel each other out, and 3 times 2 is 6 times y minus 2. And here the 3's cancel out, so I have negative 7 times y minus 2 times y plus 2. Okay, I have a bunch of simplifying to do. Let's multiply first. All right, here what I would do is multiply the two binomials together before I distribute. So y squared plus 4y plus 4, and then I'll distribute that. 3y squared plus 12y plus 12. Oops. Plus 12. Here, all I really need to do is distribute, so I'll do that. Negative 6y plus 12. Here, let's multiply the two binomials first. Notice with me they're conjugates. Y plus 2 times y minus 2. I know that my product is a difference of squares, so y squared minus 4. And now distribute the negative 7. Negative 7 y squared plus 28. All right, so we have a bunch of simplifying to work on. And we'll kind of do it all in one step. So the first thing I want to do is add 7y squared to 3y squared, combine those two terms. And I have 4y squared. Okay. Next, I'm going to combine the positive 12y and the negative 6y. And I have 6y. And then I will add 12 plus 12 here and subtract 28. I'll do it all in one step. So I have negative 4. Okay. Equal to 0. Please make sure that you check. I made a mistake here. That first term should be 10y squared because I added 7y to both sides. Okay. So this is a trinomial, a quadratic expression. It's equal to 0, so I'm ready to solve. But before I do that, I notice that I have a GCF that I can factor out. So I'll do that. So I like working with the smaller numbers. So we have 10y squared plus 3y minus 2 is equal to 0. Oh my goodness, here we go. 5y squared plus 3y minus 2. I'm sorry about that. Now I need to factor this. Here we go. I need to make a mistake. Remember that when a is a number other than 1, you need to make a mistake. So 5y and 5y. I need two numbers whose product equals negative 10 and their sum equals positive 3. So I have negative 5 and positive 2. And then I need to correct my mistake by dividing one of these by 5. So we have y minus 1 times 5y plus 2 is equal to 0. Let's solve. Y equals 1 and y equals negative 2/5. So in this case, I have two solutions. Don't forget that you always have to go back and make sure and see if any one of those is extraneous. So let's go back to the original problem and plug in y is 1 and y is negative 2/5 and see if that would make a denominator 0. And it doesn't. So those are two solutions. Number 7. Okay, let me first find the least common denominator for this equation. Look at our denominators and I'll factor them. This is 3 times n plus 2. This is 5 times n plus 2. And this is 5. So my least common denominator is going to be 15 times n plus 2. Okay, so let me rewrite this problem so that I can give myself room to multiply every term by the LCD and to eliminate all of my denominators. So I'll rewrite it. N over 3 times n plus 2 minus n over 5 times n plus 2 is equal to 2/5. Okay, now let's work on eliminating all of these denominators. I'm going to multiply by 15n plus 2 over 1, by 15n plus 2 over 1, and by 15n plus 2 over 1. Now these are all multiplication. All right, so here I can cancel, and there I can cancel, and here I can bring down 5n. So here this is a 3, and that cancels. So here I can bring down 3n. And here I can cancel. That's going to be a 3. So I have 3 times n plus 2 times 2. That's the same as 6 times n plus 2. So I'm going to go ahead and distribute that. 6n plus 12. Let's simplify. Negative n equals, let's do this again. 5n minus 3n is 2n equals 6n plus 12. Subtract 6n from both sides. I have negative 4n is equal to 12. Let's divide both sides by negative 4, and n equals negative 3. Let's remember to go back and check to see if that would be an extraneous solution. If n equals negative 3, would that make any of my denominators 0? The answer is no, therefore that's my solution. Okay, number 8, here we go. First thing I have to do is take a look at this problem, factor the denominators that I can factor to make it easier to find the least common denominator. All right, so my least common denominator here is c times c plus 2. All right, so I'm going to rewrite this expression with room to multiply every term by c times c plus 2 so that I can eliminate the denominators. Okay, so I have 1 over 1 plus 1 over c plus 2 equal to 28 over c times c plus 2. Okay, so I'm going to multiply by c times c plus 2, c times c plus 2, and c times c plus 2. And again, this will eliminate all of my denominators so that I have an equation that I can solve easily. Okay, so here c times c plus 2 times 1 is c times c plus 2. Here the c plus 2's cancel each other, so I have c. And here the c plus 2 cancel each other, the c's also cancel each other, so I'm left with 28. All right, let's simplify and solve. I have c squared plus 2c plus c is equal to 28. Let's combine like terms and make this equal to 0. So I have c squared plus 3c minus 28 is equal to 0. Now we can go ahead and factor. I have two numbers. Their product is negative 28 and their sum is 3. So I know those numbers are positive 7 and negative 4. And let's solve for each solution. If c plus 7 equals 0, then c is negative 7. If c minus 4 equals 0, I know that c equals positive 4. Okay, always go back and give it a quick check and make sure to see if any of these would be extraneous. And how we do that is we go back to the original equation up here and plug in those numbers. Okay, if any of those solutions makes a denominator equal to 0, then we know it's extraneous. Okay, and in this case, neither one of those is extraneous, so the solutions are negative 7 and positive 4. Okay, number 9. My LCD for number 9 is n minus 5. Okay, go ahead and work this one out yourself. Come back and check your answer. Okay. When I first solve for this rational equation, my solution says n equals 5. But when I go back to check if that's a valid solution, I notice that it is not. If I plug 5 into my denominators, it makes my denominator equal to 0. Therefore, for number 9, there's no solution. Try number 10 on your own. Just real quick for number 10, the least common denominator is b minus 2 times b plus 2. Okay, please check your answer. B equals negative 1. Okay, for a little extra practice, I'll give you two problems, number 2 and number 6, where you can use cross products to solve. And then 2 more, 14 and 16, where you will use least common denominator to eliminate and solve. Alrighty, have a great night. God bless you, and see you tomorrow.